चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग टाइम. In this video, we'll talk about the selective acknowledgement and window size and about the MSS. MSS we already talked about in the last video also. MS is the TCP segment length, maximum segment length which sender and receiver can exchange. Okay. And if we talk about the window size, you can say window size here. Put the definition here. It's a value determine the amount data that sender can transmit before receiving an acknowledgement from the receiver. It used to control flow of data and prevent from sending or overwhelming the receiver too much of data. What do you mean that? Like in this topology, we have a two router XRV1 and XRV2. So you can say TCP window size is buffer on each side. Okay, let's suppose XRV1 is have to send some data to XRV2. So it is the amount of data that XRV1 can send to the XRV2, and after that it will wait for the acknowledgement. Okay, and let's suppose this both side window size is 15,000 bytes. Okay, 15,000 bytes, and MSS is 1500 bytes. So XRV can do, XRV will send the 1500 packets, 1500 size of packet to the XRV2, and after that it will wait for the acknowledgement. Okay, and what is the use of selective acknowledgements? Like no, same thing. Like we have a window size of 15,000 bytes and MSS size is 1500 bytes. To to use that full window size, this XRV1 have to send the 10 packets, 10 packet of the MSS of 1500 byte each. What will happen in that case during this transmission of data from XRV1 to XRV2? Let's suppose something happened in between due to the bad network condition or something happened to link flow packet loss. If any of the segment got lost, okay, he has sent the 10 segment. Okay, out of the 10 segment, let's suppose one segment got lost. Okay, without the selective acknowledgement, what will happen? So in the case of any loss of the packet within a window, require the entire window need to be retransmit unless TCP stack on the server on both of the side either not using the like new feature like the selective acknowledgement. XRV1 have to send the full 10 segment again. Okay, but with the selective acknowledgement, what can be achieved is XRV2 can like he have sent the 1 to 10 segment, and let's suppose segment number 5 got lost. Okay, so with the help of SAK selective acknowledgement, XRV1 will send the acknowledgement from for the packet 1 to 4 and then 6 to 10, and it will not send the acknowledgement for the packet number 5 as it goes the packet number as it have lost the packet 5 due to the network condition, something due to some other reasons. Okay, so this is the use of selective acknowledgement. So with the help of SAK, receiver can send the acknowledgement to the sender for the received segment. So to explore all these options like MSS, window scale, and selective acknowledgement, and how window size got reduced when sender and receiver exchange the data, when data got exchanged with the two endpoints, and how we can get the what is the TCP throughput we can get from this link. Uh, okay, and what should be the optimum window size? I have enabled the SSH in both of the router, and these are the IP addresses configured on the link. Here on the XRE1, we have an interface IP address is 192.168.1.1, and here on the XRV2, 192.168.1.2 IP address with the /30 subnet I've configured. And I have done the SSH from this router to this router, XRV1 to XRV2, and after that I took the Wireshark capture. Let's go through the Wireshark capture. So here we have a Wireshark capture. As you know how to filter the traffic, so let me put the TCP. As you want to capture the, as you want to put the filter for the TCP, I type the name TCP in the filter bar. So here we have a TCP traffic, okay, which got exchanged between the source IP address 192.168.1.1 and destination 192.168.1.2. Okay, and here you can see that this is the first packet in the TCP handshake scene, and this is the second one scene ACK, then ACK. Okay, so most of the thing which we discussed in the TCP option field got exchanged in the handshake during the time of the handshake only. Let explore the things which got exchanged in the handshake. Okay, so I've select the first packet with the scene packet. Here, if you come down the scene packet in the trees, in the TCP header, under that in the option field, here we have this MSS is 1460, And if I were to see the window, it's 16384, okay, and multiply by the 2. Window scale factor is 1 here, okay. And similar way for the from the side of 1.2, here seen an act vector says is also saying the window 16384 and scale factor is 0 multiplied by the 1, okay. Maximum segment side is 1460. These are the things which required us to calculate the TCP throughput, and which we have to check. I have put the column here. What I've done, I have just click on this calculated window size. After that, I have done apply as a column. So this is the reason we are able to see all of the things here. Calculated window size also. Here is showing the TCP segment length. Correct. Okay. So here you can see that in the three-way handshake, TCP segment length is 0. Okay. TCP segment length is, there is no data packet, there is no data it got exchanged, only handshake is in this case. And here they are both on the side are saying our TCP window size is 16384. Okay. And look at this packet number 4. This packet is sent by the 1.1 towards the 1.2, okay, and TCP segment length is 19, okay, okay. So this host 1.1 is sending a data towards the host 1.2, okay, and it sent the data is 19 byte, okay. Here you can see that in the below fifth number packet, host 1.2 is sending a acknowledgement. If you come here, okay, here you can see the flag in the downside. I select the packet number 5. He's sending the acknowledgement. Okay, he have received the data. Okay, he have received the 19 byte of data, which is sent in the packet number 4. Okay, it's also reducing the size of the window size. Okay, because now you here in the packet number 4 is send the 1.1 have sent the 19 byte of data. So earlier window size for the 1.2 was 16384. Okay, 16384 minus 19. After that, this value came 16365. Okay, let's see the one more packet here. Here you can see then packet number 8. 1.2 is sending a data to 1.1. TCP segment length is 224. Okay, and here in the downside, if you see this one 65294 packet. Okay, 1.1 is sending acknowledgement also. Here is an acknowledgement bit is set, and it's reducing the TCP window size. Okay, because 1.2 have sent the data. So who will process the data? 1.1. 1.1 will processing the data. So meanwhile, while processing the data in the buffer, so he also sending, okay, I received the data, I will process, and this is my the reduced window size. Okay. And here you are seeing the updated values. So here you can see that they both side have updated their TCP window. Initially doing the handshake, they were saying that our window size was 16384. Here they send the TCP window update. After that, both side have said we will use the TCP window size is 65518. So now we have checked the window size. Let's see the initial round trip time also, as that is also required to calculate the TCP throughput. Okay. So here in the way the scene and act flag is set in the packet number 2, if we come down in the sequence acknowledgement analysis, here is the RTT to acknowledgement segment was, here is telling the initial round trip time is 0.08 millisecond. Okay, so this is how we can see what is the round trip time, what is the latency. So in the TCP three-way handshake, where the packet scene and act packet will come, in the selective acknowledgement analysis, we can found this value. Parsec is calculating initial round trip time. Here in this packet is showing the 0.08 second. Okay, so let's go for the calculation for the TCP throughput. So as we have checked now how to check the window size, how window size got reduced when one side set the data and the other side acknowledge it. Okay, and we have also seen it how to check in the selective acknowledgement packet in the handshake initial round trip time. Okay, so with this value we can get the TCP throughput. So here I assuming like the window size is 65518 byte. Okay, which we have seen, I'm converting to bits, so that's why I'm multiplying by the 8. So this will the value 524144. Okay, and round trip time is the 0.026 second we have to. Okay, and throughput divide by this, so you can see that 20 mbps around. So now you say I have a link of 1 gig and I'm getting a throughput only 20 mbps. So what should be the window size to get a optimal throughput? So you can get the good throughput. Here I put the like again sync. We have the round trip time is 0.026 second and link bandwidth is 1 gig. So I put the 1 after that 90 I placed. To get the optimal window size, what we can do, we can multiply link bandwidth with the round trip time. So after that I'm dividing the 8, so you can say that 3 to 5, 4 times 0 could be the can be the optimal window size of both the server side. But main thing we need to take in the consideration that while we are putting the window size, large windows in both of the server end, so ultimately this require a more memory. So that is the one thing we can take in the consideration. Okay, and rest thing I already explained you in the window size and we cover. And one more thing is maximum latency for the required throughput. Okay, if we have to same, we are again playing with the similar formula. What we can do, we can divide the TCP window size with the TCP required throughput. What is the throughput we are looking for? If we divide with the window size, we will get the maximum latency also.